Today, we are going to untangle one of the toughest challenges out there, digital resilience. We're going to connect the dots between the brittle systems of the past, the hidden risks in our software today, and the very real threats of the future. It turns out they're all connected, and a powerful new playbook is emerging to finally get a handle on it all.
Just let that sink in for a second. The app you use for your bank, the systems controlling a power grid, the networks managing healthcare, so much of it relies on software that's basically an opaque, incredibly complex, and honestly a fundamentally fragile black box. And that, right there, is the heart of the problem we're digging into. All right, so to really get our heads around the solution, we've got to carefully untangle the problem first. We're going to expose all the different layers of risk in our digital world, starting right at the bottom, with the foundations we've all inherited.
In that foundation, a lot of the time, it's built on pure fragility. We're talking about old, brittle, legacy code. Systems written decades ago for a completely different world that are somehow, against all odds, still running critical operations today. This is the first knot we really need to examine.
And when you put them side by side, the difference is, well, it's night and day. These legacy systems, often running on old languages like COBOL, aren't just expensive to keep alive. They can actually slash efficiency by up to 25%. They lack modern security features by design, and trying to integrate them with new tools is a total nightmare. It's a huge anchor holding back security and innovation.
And believe me, this isn't some theoretical problem. This number right here, that's the cost of TSB Bank's failed system migration back in 2018. We're talking $330 million on top of what they already planned to spend, and that doesn't even count the fraud losses and the hit to the reputation. It's a brutal reminder of the real money at stake here.
Okay, so the TSB failure was a disaster you could see. But that brings us to the next layer of risk. What if the real danger is invisible? See, the modern world runs on software that's pieced together from countless third-party components, creating this huge, sprawling supply chain that's almost totally invisible to us.
So how do you fight a hidden risk? The answer is transparency. A software bill of materials, or an SBOM, is basically just what it sounds like, a list of ingredients for your software. It gives you a clear look at every single component you're using. And this idea is so critical that the US government, through an executive order, now requires SBOMs for any software it buys.
Now, as complicated as legacy systems and supply chains are, there's an even bigger kind of existential threat looming on the horizon, the quantum computer. And this is not science fiction anymore. It's a future technology that creates a very real and very present danger for us today.
This quote just nails the problem. It's a strategy that security folks call harvest now, decrypt later. Basically, adversaries are vacuuming up our most sensitive, encrypted data right now, and they're just sitting on it, knowing that one day soon, a quantum computer will be able to crack that encryption and read it all like an open book.
This timeline shows you exactly why this is so urgent. Just look at the sequence. The vulnerability isn't in the future when these computers show up. The vulnerability is now. The data being harvested today is the ticking time bomb. Every secret we think is safely locked away has a potential expiration date.
Okay, so we've laid out the scale of the problem. Brittle foundations, hidden supply chains, and this looming quantum threat. It's a lot, but the good news is a new playbook is emerging to turn all this fragility into genuine, durable resilience. And this new playbook is built on 3 simple but incredibly powerful principles that completely flip the old security model on its head. Number 1, assume nothing. Number 2, demand transparency. And number 3, build for change. Let's dive into what each of these actually means.
So this first principle is a massive philosophical shift called zero trust. The old idea of a secure network perimeter, the castle with a moat, it's dead. Instead, the motto is never trust, always verify. Your identity becomes the new center of security, and every single request for access has to be proven, every single time, no matter where it's coming from.
The second principle, demanding transparency, is where those SBOMs we talked about become absolutely essential. But it's also being driven by new, really powerful regulations, like the EU's Digital Operational Resilience Act, or DORA, which is basically forcing organizations to get a serious grip on their digital operations and who they depend on.
DORA is a perfect example of this in action. Starting in 2025, it's making financial firms manage their risks even when they use third-party cloud providers. It demands strong authentication and, this is the really key part, an exit strategy. That means you have to be able to pull your data out of a provider securely. It's led to these new practices like cyber shredding, which is where you just delete the encryption key, making any data left behind completely useless. Poof, it's gone.
And finally, our third principle directly takes on that quantum threat. It's called crypto agility. It's the simple but brilliant idea that we have to build our systems today so we can easily swap out our cryptographic algorithms tomorrow. This is our #1 defense against harvest now, decrypt later. It ensures that when a better lock is invented, we can deploy it everywhere immediately.
So we've journeyed from this tangled problem all the way to the core principles of a new solution, which brings us to the final, and let's be honest, the most important question. Where do you even start? How do you actually begin this journey? Well, the first step, according to the U.S. National Institute of Standards and Technology, or NIST, and these are the folks who set the gold standard for this stuff, it isn't some huge complicated project. It's just discovery. You have to know what you have. That means creating a detailed inventory of all your cryptographic assets, a cryptography bill of materials, or a CBOM. Think about it. You can't protect what you don't even know exists. Once you have that map, then you can figure out what needs to be upgraded to those new quantum-resistant standards.
So make no mistake about it, this shift is already well underway. The very foundations of our digital world are being rebuilt on these new principles of transparency, verification, and adaptation. The real question isn't if this change is coming, it's whether your organization is truly ready to make the leap from a fragile past to a resilient future.